we're going to jump into a new section. We're going to do the sum and difference formulae. It says formulas there, but notice down here, it says formulae, or formulae, formulae. Why do I have it spelled two different ways? Is that just a typo? Is that just a typo? No, they're not two different things. They're actually the same thing. They are the same thing. Riddle me this, Batman. Where does the word formula come from? Latin. Latin. And Latin does not do its plurals the same way that Greek or that English does. How do we do plurals in English? We just slap an S on the back of it usually. There's a couple of exceptions, right? What's the plural for deer? Deer. Right? What's the plural for goose? Geese. What's the plural for rabbit? I didn't know rabbits were Jewish. Well, I guess. Anyhow.
Wouldn't that be a fun meeting too?
All right. Please tip your waitresses. Take my wife, please. All right. So, in Latin, some words, they put an E. So, the singular for formula is formula. The plural for formula is formulae. And they just throw an E on there. So this makes an I or an A sound. Okay? So it's just a different way to say the same thing. Either way to say the plural formula is correct. But if you want to sound superior, you use Latin. Right? Right? Okay. But at the end of this lesson, we will be able to use the sum and difference formulas to evaluate trig functions, verify trig identities, and solve trig equations. Can I help you out there, Will? Oh, okay. All right. So let's get started. First thing I want you to do, we are not going to focus on this worksheet initially. We are going to come to this. Right now, I want you to start in your notebook and start by drawing a unit circle. And in the unit circle, I know, taking notes in class, I am such a tyrant. I'm such a tyrant. I want you to draw two rays in standard position whose terminal rays are in the first quadrant. Now there is a lot of stuff going on in that statement, right? What do I mean by in standard position? Can you take those headphones off, please, Logan? Thank you, sir. What do I mean by in standard position? Who remembers the definition of in standard position? I know I'm going to be disappointed by this recording. The recording? Oh, standard position. What does it mean? What is the definition of an angle being in standard position? What's that? It does have a standard. What is the standard, though? So the positive x-axis is important here. I should change the color of that so we can see it. Let's put it. You know what my favorite color on this is? Baby turd. I love baby turd. All right. So, I've recorded this, Jet. So, well, the initial standard position means that the initial side of the angle coincides with the positive x-axis. That's what it means for it to be in standard position. But it doesn't say anything about the terminal side. But I say that up here, right? Oh, snap. Yeah. I say the terminal rays are in the first quadrant. So, the green one right here and the blue one right there are both in the first quadrant, are they not? Okay, so we're cooking with gas, right? Now, second page. You don't need to go to the second page. You can continue this on the first page. But I want you to add those two angles. Your angles for the blue one, we'll call that alpha. For the green one, we're going to call that beta. How do I know? Why do I call these alpha and beta? Why not A and B?
Phonetics is something.
Well, they are, but I typically use Greek letters when I'm doing angle measures in trig. Okay? And these are Greek letters. Alpha looks like an A. Well, it does. It looks like an A, don't it? Except there's a second tail to it, right? And beta looks like a B, except it has a tail to it. Okay? Difference between alpha and A, beta and B. It's basically the difference between monkeys and apes, right? Monkeys have a tail, apes do not, right? You guys knew that, right?
Yeah.
Yeah. Monkeys and apes. Okay. So, now if the green angle is beta and the blue angle is alpha, what is the red angle? There is no Charlie in Greek.
That's phonetics.
Delta is the next, actually, I think gamma is the next letter in the Greek. I think it goes alpha, beta, gamma, delta. But no, it's not gamma. How did I get the red?
Alpha plus.
Yeah. Yeah. So the red angle is alpha plus beta. Now, here's my proposition. If I know the sine and cosine of my green angle, and I know the sine and cosine of my blue angle, I should be able to find the cosine and sine of my red angle. But it's not obvious that I just simply add the two, like this cosine and this cosine. Can I just add those cosines together to get my new cosine? No, because this is going to be negative, right? Can I just add my sines together and get a new sine? No, because this sine is somewhere between this sine and this sine. I can't just add these two together to get that one. So there's something else going on here, and that's what the worksheet is about, okay? So at the last page, I want you to label the points on the unit circle thusly. Except, we've been using alpha and beta, and for some reason I put theta on the page. So if you want to throw an eraser at my head, you can, because this should be beta, and that should be beta, and this should be beta. I don't know why I put theta in there. Oh, and so you guys should have betas in there instead of thetas. For some reason I put thetas. Thetas are Greek.
I know, but there's a few letters in between.
Yes, there are. Okay, so these are going to be cosine beta plus alpha, sine beta plus alpha. There's cosine beta, sine beta, cosine alpha, sine alpha. Clear as mud? Crystal clear mud.
I don't think that's mud.
All right. It's mud with a very low dirt content. All right. May I?
You said crystal clear though.
So, we're going to this sheet next. All right? And so you got a sheet at your desk with two sides to it. One says the sine and cosine sum formula, and the other side says sine and cosine difference formulas. We're going to do the sums first. We're going to do the sums. So, on your sheet, you see, read the statement right below the picture.
Use the rectangular diagram above to answer the following questions. Use the fact that the line has in bold has a length of 1 unit.
Yes. So how long is this line right here?
One.
That's 1, right? Let's label it. That's 1. That's 1 long. 1 what? One chicken?
One anything.
1, I don't know. Let's call it, let's invent a new unit called I don't know. We'll call it 1 I don't know.
One cook.
It's 1 I don't know.
One cook.
But it's 1. It's 1 of them, right? Okay, now we're going to use that to come up with, we're going to use what our starting point is here to come up with all the rest of these boxes or lines, okay? The first thing I want you to figure out, you notice on the Google Docs kind of stinks. You notice how it doesn't have, everywhere there you see a box there? Do you see that? Yeah, alphas go in those boxes. For some reason, it showed up on my document when I was doing it, but it didn't show up when I printed it. So everywhere you see a box, that's an alpha. Follow me, Will? You see the box there? It didn't print for whatever. It printed here. It printed there, but it wouldn't print there. It made me very angry because I didn't notice it until I handed these out to the morning class. The boxes on here. It would help if you paid attention. You see the box? See the little boxes right there? Yeah? You see the box there and the box there? Those all should be alphas. For some reason, Google Docs did not recognize my alphas. Okay? But here's what I want you to do. I want you to use your knowledge of trigonometry, or not trigonometry, of geometry. Thank you, Spencer. I want you to use your knowledge of geometry to express the value of these two angles in terms of the variables that you have for the other angles, namely alpha and beta. Okay? So I want this angle to be expressed in terms of alpha and or beta, and this angle to be expressed in terms of alpha and or beta. So I'll give you a couple minutes. I'm going to pause. Does anybody have a value for 1A?
Yes.
What do you got, Jet? Alpha plus beta. So Jet says that is alpha plus beta. And how did you justify that, Jet? Well, do I have to assume? What kind of shape is this? The blue shaded thing.
Square.
Square? Use the rectangular diagram above, right? Ah, devil's in the details. It's a rectangle. So what do I know about opposite sides on a rectangle? They are parallel, yes. Okay, so they're parallel. So what?
So this line cut through both of those means that
This guy
that guy
and this guy
interior corresponding
all.
alternate interior.
Yeah, alternate interior angles. So, and what is this guy right here that I just highlighted? Not alpha beta, alpha plus beta. Alpha plus beta is a lot different than alpha beta, right? Alpha beta sounds like the evil fraternity in Revenge of the Nerds. Anybody seen that movie? You guys don't know what you're missing. You guys are going to go to college pretty soon. Revenge of the Nerds is an allegory on inclusiveness in college. You need to see it before you go to college.
Here, you can play it during class.
I could, except there's too many inappropriate moments for it to be in class. Anyhow, back to this. All right, so that's 1B, or 1A. What about 1B? Does anybody have an input on 1B? You say alpha, Morgan? Why do you say alpha?
I'm just guessing.
So that's a guess. That's a guess. Who likes that guess? Who likes this guess? Nobody likes your guess, Morgan. You're all alone. I like your guess.
Oh, is that?
I like your guess. But we don't base math on guesses, do we? Alpha, right? So let's justify this, shall we? So we've proven this guy, right? Okay. What is that guy? $90 minus beta. How do you get that, Alex? Yeah, that's 90 degrees right there, right? I know the sum of these three angles is what, Noah? What's the sum of these three angles in beta, this guy, and this guy? What are the sum of those three angles? What's the sum of three angles in a triangle? 180, right? Okay? So, take away 90 from that 180. I got 90, right? Am I done taking away angles? I got to take away beta too, right? So this is 90 minus beta. Does everybody recognize how I got there? Okay, now, how about this angle? This angle plus this angle plus this angle equal what? 180. So 180 minus 90 minus beta, right? So 180 minus 90 minus beta. So now I got to do what here? I'll do the distributing the negative, right? So that's 180 plus a negative 90 plus positive 180 or plus positive beta, right? You gonna mock me?
I usually
Are you
do.
gonna mock me? Mess with the bull. Get the horns. Get the horns. So what's this leave me if I simplify this? Isn't this 90 plus beta? 180 minus the quantity 90 minus beta? Isn't that just 90 plus beta? And then I gotta still subtract this guy, right? I distribute the negative again. Boom, boom, boom. The negative betas cancels out with the positive beta, and I get 90 minus alpha there, right? So this angle is 90 minus alpha, right? Now, the corner of the rectangle that I just wrote over, what's that angle? So 90 plus this 90 plus this guy gets me what? 180, right? So I take that 180, let's subtract that right triangle, or that right angle. 180 minus that 90 gets me 90, right? And then 90 minus this 90 minus alpha, that gets me alpha, right? Let's do that. So I got, my three angles are alpha plus beta, 90 minus beta, and then I got some unknown, right? No, I did that one already. I'm sorry. I want to do the other one. I want to do this triangle right here, right? I'm sorry. I want to do that triangle. So 90 minus alpha. Why didn't you guys stop me? We're on that one. I'm on the wrong problem. So 90 minus alpha plus 90 plus, I don't know what that angle is yet, but I know the sum of those three angles equals 180, right? And then I get x by itself. So the first thing I do is subtract 90 from both sides. Boom, boom. And this becomes 90. And then I minus right? Boom, boom, boom. These guys go away. Boom, boom, boom. These guys go away, and I'm left with alpha. So this guy is alpha. So Morgan was right. That's alpha. That is alpha. Now, this looks like a mess, so I'm going to erase some stuff so we have room to work the rest of the alpha plus, plus beta, and this is alpha. Okay, now I got some angles. Now what's it ask me for next? It says, use your knowledge of trigonometry to find the length of the following sides with respect to the appropriate angle given. 2A. What's the length of 2A? It says, with respect to the appropriate angle given. What do you think that means? How do I find the length of a side with respect to an angle? Sine or cosine? Good. Well, what angle am I given here? I'm given this guy, right? Cosine theta? Just cosine theta? Theta? You mean beta? So you're saying I'm old and my ears don't work? So it's cosine beta. Well, wait, I thought cosine of beta was adjacent over hypotenuse. Is that right? So cosine, let's call this side x for a second. So cosine of angle beta equals x over the hypotenuse, which is 1. Oh, and what's a fancy way of writing? That's a fancy way of writing what? X, right? So this guy equals cosine theta. We on board with that? Okay. Which makes this side 2b, which is this side, right? That's sine beta. Very good. So let me put that in red. That's sine of beta. Okay. Number 2 is done. I would pay attention to how this is being done because I'm going to ask you guys to do this on your own on the backside. Now, again, number 3, again, use your knowledge of trigonometry to determine the lengths of the following sides with respect to the angles and sides that you already know. So, 3A, this guy right here. What's the length of that guy? Well, if I had to say, let's call this x again. Sine of alpha I'm using the wrong trig function here. Which trig function should I be using? Cosine. Cosine alpha equals, this is angle alpha here, right? So cosine of that equals what? It equals adjacent over hypotenuse. So it equals x over, well, I found my hypotenuse already. It's cosine of beta. So now, solve for x. What do you think x is? Have you guys noticed how I teach? How many people would like me just to give you a formula and then you guys can go cranking with the formula? How many guys would like that? We would love to just play with formula, right? Why do you think I insist on going through this for every single formula that we've ever done in this class?
Teaching us the formula doesn't teach us like why we're doing it or how it works.
There's a why component to it, right? There's also a, how would I put it? There's a, you learn better. You don't have to memorize as much. but it's also I think a skeptical mindset is healthy. What do I mean by that, Sam? What do I mean by a skeptical mindset?
Always think something else.
I mean, you're going into the wrong profession for a skeptical mindset, right? You're going into a profession where it's best just to do what you're told, right?
Yeah.
But questioning, not believing things just because somebody told you, right? I mean, if think about a leader that you've had in your life, whether it be a political figure or a teacher or maybe a boss that you had at a job or something that you didn't respect all that much. Okay, has everybody been there? You're like, this person tells you to do something, and you're like, yeah, but it's that person, and I really don't trust that person. We've been there, right? What do you think, Ian? You been there? Okay. Do we just do and believe things that that person says? We should always have that skeptical inquiry, right? I shouldn't just say, oh, well, I'll do this because my teacher said to. Human history is cratered with events that came about because good people just did what they were told by bad people who studied World War II. Good people did things that bad people told them to, and what happened? 30 million people died, right? And then once you start doing things that bad people tell you to, can you call yourself a good person anymore? Can you? I think Nuremberg kind of made that point that you can't do that anymore. Nuremberg, well, what did Nuremberg do though? Nuremberg said, you were following orders, but that's not an excuse for what you did, right? You can't say, they told me to do it, and that's why I did all these unspeakable things. Some things are beyond that, right? And what I'm trying to do is I'm trying to get you guys to understand.
Sorry for the interruption at this time. The Lucky Bin is open for last-minute processes or accessories and is open until the end of the day. Thank you.
Anyhow, long story short, I'm trying to get you guys to understand that this stuff, there's a basis behind it, right, Will? There's a basis behind it. And we're not just doing it because I said to do it. Okay? That's an appeal to authority, and it's how it's the road to unhappiness. It is. It is. So anyhow, where were we? I'm back off my tangent. Oh, what is X? Solve for X. Right here. X is cosine alpha? Not cosine alpha times beta. Cosine alpha times cosine beta, right? There's a difference there, right? So this is cosine alpha times cosine beta. What do you think 3b is? Sine alpha times what? Yeah, sine alpha times cosine beta. Good. So this sine alpha times cosine beta. So we're making progress. Now, 3c, this side right here. What's an expression for this? Lyndon, this will be up on Classroom. Have a good one. How do I find 3c? Let's call this x now. Sine of alpha, this is alpha, right? Sine alpha equals 1 over what? What is sine? Opposite over hypotenuse. Good. Well, what's the opposite side of alpha here? I called it x here, right? So this equals x over, and what's my hypotenuse? What's the length of my hypotenuse? Sine beta, right? So x over sine beta. And then to solve for x, I just simply multiply both sides by sine beta. And x equals sine alpha times sine beta. Okay. Now, 3D. If this is sine alpha times sine beta, what do you think this is? Cosine alpha times sine beta. Okay? Now, we're getting to the point where we can wrap this all up. 4a. How can I give you, there's two ways to define 4a. First of all, I can define 4a with respect to this angle. How would I do that? I'll do my baby turd triangle. My baby turd triangle is right here. So there's my right triangle, right? What trig function would I use to find 4a, Hallie? Do I have an adjacent side yet? No. I'm looking for the opposite side, right? And I have an angle measured. And I have a hypotenuse. This is the opposite side, right? So I want to use sine. Sine is opposite over hypotenuse. Well, the hypotenuse is 1. So this would just be, go back to red, cosine of, thank you. This would be sine of alpha plus beta. But there's another way to talk about the length of this side. Because that side and this side are what to each other?
Parallel.
They're parallel, but that's not the word I'm on. They're equal in length, right? They're equal in length. So is there another expression that I can use to explain this side? This guy plus that guy, right? And there is your first sum formula. Sine of alpha plus beta equals this plus this. That goes in the bottom margin yon hither. The second one's a little bit more challenging. But because we're trying to find, go back to baby turd. We're trying to go back to this side, right? Now that is what? What trig function do I use when I'm relating it to this angle? I do cosine, right? So this is cosine of alpha plus beta. And now I got to relate it to this side right here. I want to do baby turd again. I want to compare it to this side. Well, this side that I just highlighted is equal to what and what? This plus this, right? How you doing, Zach?
Pretty good. I'm gonna just leave this on my desk here.
Thank you. Thank you. Actually, is that the assignment?
Yeah.
Top right basket.
Okay.
And pop a staple in if it's multi-page. So, how would I do that? Well, I know cosine of this business plus this guy, those two added to each other equals this guy, right? So can I just do some simple algebra and get this guy by itself? Yeah, I can just subtract this from both sides. So then I get cosine alpha plus beta equals, and it was cosine alpha times cosine beta minus sine alpha sine beta. And there is your other sum formula. Okay? Would it be easier for me to give you these formulas? It would turn an hour and a half lesson into about a 5-minute lesson. I'd say, here, have the formulas, go crazy. But my hope is you guys have an understanding of how these things are reasoned. We just didn't make these things up. They're derived, and this is one method which to derive it. Okay? Now I want you guys to do the same thing with the difference formula. Okay? Difference formula you're going to do on your own. Okay? You're not going to get the assignment for this lesson just yet. It will be posted to the classroom and all that jazz, but we got more stuff to talk about tomorrow before I actually hand out the assignment. But doing this is going to be part of it. Okay? So I'll have you work on that now.